Hello, I'm Seema and welcome to part 32 of the chapter Organic Chemistry, Some Basic Principles and Techniques. We have been discussing the various techniques of methods of purification of organic compounds. And I told you the various methods of purification are sublimation, crystallization, distillation, differential extraction, and chromatography. We have done the first two methods in the previous video, that is sublimation and crystallization. In this video, I'm going to start the third method, that is distillation. Now, distillation can be categorized into four types. The first is simple distillation, where I explain what distillation is to you and how it is done simply. Then you have fractional distillation. Then we have distillation under reduced pressure and steam distillation. In this video, I'm going to do only two parts, that is simple distillation and fractional distillation. So let us come to distillation. You know, when you have liquids that have a difference in their boiling point, whenever we have to separate the components of a mixture, we always have to find one property that is different in the substances or in the components. And that one property that is different, we make that the weapon. You know, when you want two friends to, you want to create a rift between them, you want to create a fight between them, what do? You find a point of difference. And on the basis of that point of difference, you can create a separation between them. It's the same. When you have two components in a mixture, you have to find that one point that is different and then use that to separate them. That is what we do in all these methods of purification. That is what we do. We look for that one property. When you have two components or two liquids which have different boiling points, if you have a mixture of two liquids or more than two liquids, and they have different boiling points, you can use this property to separate the components. And that is done by the method of distillation. So let us see, the first method is simple distillation, where you understand what, since they have different boiling points, how do we use that to separate the components? So if you have two liquids and they both have different boiling points, you start heating them. And when you heat them, they vaporize. But both the liquids vaporize at different temperatures. Let us say that the mixture was at room temperature and you start heating it up. As you heat it up, that fraction or that liquid or that compound which boils at a lower temperature will start boiling first. And that component which boils at a higher temperature will boil later. So what will you do? The one which starts boiling first, its vapors would be formed. You know vapors are hot, so they rise up. They are gaseous in nature, so they rise up. And as they rise up, they come here and we stop it. We have a stopper and we have a thermometer here. And we are maintaining the temperature in such a way that the temperature is close, slightly above the boiling point of the first liquid, the lower boiling liquid, but it is lesser than the boiling point of the other component. So very cleverly or smartly, we are going to maintain that temperature to the boiling point, slightly above the boiling point of the lower boiling fraction. So what happens? That lower boiling compound will keep on boiling and its vapors will keep on rising, and since this is stoppered, it is closed, the vapors cannot escape. So where do they escape? There's a tube on the side. So the vapors start entering this tube. It is known as the delivery tube. So they start entering the delivery tube, and outside the delivery tube, we have another tube, which is like, you could say, a jacket. So there is one tube in the middle and another tube above it, and this tube has got two openings. The lower opening is where you allow cold water to go up, and the upper opening is the outlet where you allow the water to come out. So you will keep putting in or pushing in cold water in the outer tube. Why are you doing this? Because the vapors which are coming here at that temperature, when they come in contact with the cool walls of the inner tube, because the inner tube walls will become cool due to the cold water which is circulating around it, that will turn the glass walls cold. So these cool walls, the vapors, they start condensing when they come in contact with the cool walls. And as they condense, what you get here is droplets. You get drops of the liquid which had the lower boiling point. Now, after we have collected this liquid, we wait for some time and we continue to increase. We find that now no more liquid is coming out and the temperature is being maintained. So we find that one of the components whose boiling point was lower has totally come out and we have separated it out. Now, for the second component, we raise the temperature to the boiling point of the higher boiling compound, the compound which has a higher boiling point. And now that will rise as vapors. It will also be condensed and you will take a separate beaker or a flask and you will collect that second liquid. So if you have a mixture of more than one compounds or two compounds also, you can, and their boiling points are quite apart. They are so, the difference in the boiling point is so much that it is possible for you to maintain the temperatures in such a way that first you get the lowest boiling liquid, then you get the one that has medium boiling point, and in the end you will get the last fraction which had the highest boiling point. And the method is the same. So this is simple distillation. What did we do? We used the process of distillation using what was the tool that the difference in their boiling point of the different compounds, we used that to separate the compounds. So simple distillation is used to separate volatile liquids from non-volatile liquids. That is, it is possible that one of the liquids boils over, the other one does not, and needs a very high temperature. So you would just separate out the first fraction and leave the other one as a liquid, because you already, if they were just two components, you will be left behind with the non-boiling fraction. Or if you have, let us say, salt and water. Salt is a solid, but it is a soluble solid. So the water will evaporate at 100 degrees Celsius and the water vapors can be condensed by passing it through the condenser, and the salt will be left behind. So you can separate volatile liquids from non-volatile substances, or when the boiling points of different liquids is sufficiently different, even in those situations you can separate the liquids by simple distillation. Now, an example here. Toluene has a boiling point of 110 degrees Celsius and benzene has a boiling point of 80 degrees Celsius. Now this temperature difference is a difference of 30 degrees Celsius, which is pretty high. Since the difference is large, what do? We start heating the mixture of benzene and toluene, and we maintain the temperature of this flask at about 85 degrees Celsius. So we do not bring it up to 110 or anywhere close to 100, but it should be slightly above 80. And under these conditions, what will happen? You will start getting the vapors of benzene. But remember, when you have molecules, even if you have 1 mole of a liquid, the number of molecules is so large, it is equal to the Avogadro's number. That is 6.023 into 10 to the power 23 molecules of that substance. So some of the molecules will definitely have more energy. So what happens, even if you are carrying out the distillation and benzene has a boiling point of 80 degrees Celsius, some molecules of toluene will still have enough energy that they can escape in the form of vapors. So although this is a very good technique to separate out the liquids, but when you get the benzene here, so what will you get? When you start heating it up to 85 degrees, you will get benzene here. But some molecules of toluene will also be collected. So you will not get absolutely 100% pure benzene, but you will get a 80 mole percent. That is, if you had 100 moles of the mixture, 50-50 mixture, if you had say 50 moles of toluene and 50 moles of benzene, then in this flask, by the process of simple distillation, you will get 80 mole percentage of benzene. In this, about 20 mole percent, 20 moles per 100 of toluene would also be there. So you will get a liquid of only 80% purity by simple distillation. So although distillation is a good technique to use it is best to use distillation when you have a liquid with an insoluble solid. A soluble solid like salt and water. But if you have different liquids, you will never get 100% pure liquid. So what do you do? What should you do? When you get 80% liquid, then this time we had a 50% mixture. What should I do? I should take this and I should put it back in a flask and I should start heating this. Or I could make an apparatus where instead of having a flask like this, a conical flask, I have a round bottom flask and I have a flame under this also. So when I get 50% mixture I started with, I got an 80% mixture. In the second flask, I started heating the second flask also, and I rose it up to again 85 degrees, and again I got my benzene, and this time after a second distillation, in this flask the benzene would be about 97 mole percent of benzene, which is quite pure. But yet you will have about 3% of impurity, that is toluene. You would still have 3% toluene in it. And now, if this was also a flask and I had a flame under this, then I could have still raised the temperature of the third flask to about 85 degrees Celsius. Again, I would have applied a condenser and the process would have been repeated. And this time I might get benzene, which would be almost 100%. But I wasted a lot of fuel. It took me a long time because first I turned the benzene into vapors first time, then I condensed them, then I collected them as a liquid, then I heated it up again, then I condensed it, then I collected it third time, then I heated it again and I collected it the fourth time to get almost 100% pure benzene. So this is a long process. Is there a way that you could reduce these steps? Is there a way that you could do that you would not have to go on distilling it again and again? Yes, there is a way, and that is known as fractional distillation. You do not carry out distillation in a single step or in repeated steps. What you do is you add a column here itself. You add a kind of a column which allows the liquid that is vaporized to turn back into liquid and vaporize back again, turn back into a liquid, vaporize again. What we are doing here, that can happen in a column right here. And that is where we introduce fractional distillation. When the difference between the boiling points of the liquids is not much, under those conditions, we use fractional distillation. How is it done? Take a look here. This is a column which has got some filling in it, which is known as the fractional distillation column, and it has a filling in it, and the filling is of something that does not fall into it's like something embedded in a gel or something which does not fall into the flask, but it allows the vapors to pass through. So when the vapors of the mixture, let us say we take the same mixture of toluene and benzene, we bring the temperature to about 85 degrees Celsius, and in the first distillation, what was the percentage? You got about 80% of benzene, right? So 80% benzene and 20% toluene rises in this column. And what happens? Whose boiling point is more? Toluene's boiling point is more, and those 20% molecules had more energy, therefore they also escaped along with the benzene. But when they come and meet these balls, these impediments on the way which kind of cool it down, the vapors of toluene, which has a higher boiling point, will turn into a liquid. And when they turn into a liquid, they'll start falling back. And when they start falling back, at the same time, the molecules of benzene which were rising, which have a boiling point of 80 degrees Celsius, not only do the impediments or the filling, does that reduce the temperature of the rising vapors, but these rising vapors of benzene, they may absorb some of that heat from the toluene and they would rise even higher up, while the toluene will keep falling down. So what will happen? You have just increased the column, the length of the column, so that the vapors, the idea is that the vapors which were converted into a liquid, they should turn back into a liquid, then they should go back into vapors. So you should boil them, vaporize them, condense them, and then again vaporize them. That is happening automatically because of the vapors which are rising. They fall a little due to turning into a liquid. Then the rising vapors may increase the temperature of some of those toluene molecules. So let us say at this level, instead of 80%, 80 mole percent of benzene which rose, at this point you start getting about 85%, here you start getting about 90%, here you start getting about 95%, and by the time the vapors, and what is happening and this column in the diagram, I've made it a small column. It could be a tall tower. Industrially, you have towers like this. And as the vapors are rising, they keep falling off, re-vaporizing, falling off, re-vaporizing, and toluene basically every time, since it has a higher boiling point, would have a tendency to fall back into the flask, while benzene, by the time it is collected, and then it's like it is in distillation, you pass it through the delivery tube, you have a condenser. By the time the vapors come here, they are almost 100% benzene. This technique is known as fractional distillation. And a very big use of fractional distillation is in the petroleum industry. And I made this, you must have studied this in your lower classes also, but this is a time when it's a very good time to remember it, because fractional distillation becomes, you have different types of fractionating columns. Here, when you have crude petroleum oil and you're separating the fractions of petroleum into fuel oil, lubricating oil, paraffin wax to make candles, you have asphalt or bitumen, which is used to make roads, to pave roads, fuel oil, which is used for heavy machinery, diesel oil, which is used to run trucks, large trucks, kerosene, which is used as fuel in aeroplanes, gasoline is your regular petrol, then you have gas, and there is a fuel in between, that is naphtha. So these are the different fractions of petrol which are created. When you have petroleum, crude petroleum, when it is taken out of the earth, when it is extracted, at that time you have a mixture of many hydrocarbons. So we use the process of fractional distillation here. What do? We take the crude oil and in a furnace, we boil this oil. We heat it up to about 400 degrees Celsius. And at 400 degrees Celsius, we allow it to enter into the fractionating tower. The fractionating column here is a tube, maybe 1 meter long. But here, this may be many floors long, like a multi-story building. So in the fractionating tower, you put close to the bottom of the fractionating tower, you allow the petroleum crude oil at 400 degrees Celsius to enter the tower. At this point, at 400 degrees Celsius also, you will have a part of the mixture of the petroleum, which does not vaporize. It is in the liquid form. So that just flows down and comes down, and that is the heavier fraction, which is known as the lubricating oil or paraffin wax, which is used to make candles, or asphalt or bitumen, which is used to lay down the roads. So that fraction is separated in the beginning itself, because even at 400 degrees Celsius, it does not vaporize. Now those vapors, compounds, mixture of compounds, which are about, petroleum is a mixture of hydrocarbons from C1, that is 1 carbon atom, to about 50 carbon atoms. Heavy compounds, heavy hydrocarbons and light hydrocarbons. So these various fractions, each of these is actually a mixture of compounds, mixture of hydrocarbons, which have somewhat similar boiling points, right? And they are separated. These different fractions are separated by this process of fractional distillation. So now what happens? How is the construction made? Now imagine how this tower would be. Imagine that this is the ground floor, okay? The lower floor. And then this is a room on the first floor in a multi-story building. And how are the vapors? The vapors will go up, and there are holes on the floor. Now these holes in the floor, they allow the vapors to come up. So because vapors are hot and they always rise up. So the vapors come up, and on top of every hole, which is actually a little pipe, you have an umbrella. And the umbrella is covering the different pipes. Why do we have this umbrella? Because now as the vapors rise and come up to the next floor, the temperature of the next floor is not so high. At this point, you had put in 400 degrees Celsius was the temperature of the crude oil. By the time the vapors rise up to the next floor, the temperature comes to about 370 degrees Celsius, right? About 30 degrees Celsius lesser. At this point, some of the compounds, the heavier compounds, they start turning into liquid, they start condensing. And when they condense, why do we have those umbrellas? A rainfall starts inside the room. They start turning into liquid and the drops start falling. We don't want those drops to go back into the lower floor because we want to separate out. So what we do, when they fall on the umbrella and then they trickle down and are collected on the floor. And outside, from the end of the room, you have a tube which allows the fuel oil to go out. Now this fraction, which kind of, the fraction of compounds that condense at around 370 degrees Celsius to about 300 degrees Celsius, that fraction is collected and it is known as fuel oil. And those compounds which do not condense even at about 300 and let us say 320 degrees Celsius, they escape to the next floor. So when they escape to the next floor, on the next floor, the temperature of these compounds now comes down to about 300 degrees Celsius. And again, you have those these are known as bubble caps. The bubble caps or the umbrellas, they allow the condensation starts. The vapor will anyway rise and it's a gas. It can go from around the bubble cap. But as the liquids, they start, the vapors, they start turning into liquid. They start falling on these umbrellas. And this fraction that you get at about 300 degrees Celsius is diesel. And then even at around close to slightly above 200 degrees Celsius also, the fraction did not condense. You still have vapors. Those vapors will move up to the next floor. And on this floor now, the temperature of the vapors is going on decreasing because there is no heat here. The heat was only provided in the furnace. So as the vapors are rising, they are getting cooler and cooler. So when they come here, the temperature comes down to about 200 degrees Celsius. And then you get the rainfall on this floor. And when you get the rainfall, you get the rainfall of kerosene oil. And you collect the kerosene oil from the floor because from the umbrella, the droplets fell to the floor and the floor has a pipe which allows the collection of kerosene oil. Then the vapors that did not condense even now will rise up even higher. And then on the top floor, you will get gasoline. The temperature now of the vapors is about 150 degrees Celsius and the rainfall starts and what you collect now is gasoline or petrol. And if even on this floor, as the vapors keep rising to about 20 degrees Celsius, now the component that does not, the temperature has come down to 20 degrees Celsius and yet 20 degrees Celsius is room temperature. And yet there are some compounds which will not turn into liquid even at room temperature. They remain gases. These gases are then collected and this forms your petroleum gas, which is later liquefied under pressure and put into cylinders and is used as LPG or liquefied petroleum gas. So this is how we use fractional distillation to separate out the components of petroleum, right? So these were two techniques of distillation, simple distillation and fractional distillation. In the next video, we'll be doing the other two types of distillation, which would be distillation under reduced pressure and steam distillation. So with this, I'll wind up today's video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching and bye-bye for now.